our very last lesson for this chapter, we are Unit 4, Day 3, and we are going to talk about complex rational expressions. All right, there are going to be two methods that I show you to simplify a complex rational expression. The first way we can do this is simplify the numerator and then simplify denominator, then divide. Okay, the second method, which is going to be the quicker sort of shortcut method, is going to be to multiply by a LCD for every term. And you'll see what I mean once we do a problem. Least common denominator. LCD is the least common denominator. Okay, so my question for you is, don't write this down. If I have 5/6, actually, I'll do this later. I'll do this before the shortcut method to explain to you why it works. Let's just do an example here, and I'm going to have my example 1 is 3/4 plus a half over 5/6 minus 7/12. And we're going to do the same problem two different ways. We're going to use method 1 and we're going to use method 2. It's for me to show you both. Okay, so for method 1, what did I tell you to do? I said basically simplify the numerator, simplify the denominator, then do what? Divide. So here we're going to have 3/4 plus 1/2. That whole quantity, I'm going to put it in parentheses because it needs to be done first. This fraction acts like almost like a grouping, right? And then it's divided by 5/6 minus 7/12. Going to do what's in the parentheses first. So I need to first, for the first parenthesis, make a common denominator. So if I have 3/4 and a half, I'm looking at 4 and 2. What is my common denominator? 4. So we're going to say 3/4 plus, multiply by 2 top and bottom, 2/4. And then in the second parenthesis, isn't my common denominator 12? So this is going to be 10/12 minus 7/12. So now I will have 5/4 divided by 3/12. Keep, change, flip, right? We're dividing now. Keep, change the division to multiplication. We're going to flip the 3/12 to 12/3. Can I cross simplify now? 4 goes into 12. 3 times 3 divided by 3 is 1. So what are we left with? 5 times 1 is 5. Did I go too fast for you all? Following along? This is the longer method. This is the longer method. Now let's talk about method 2. right, before we do this exact same problem, if I have, I don't know, I'm going to have 3/5. If I have 3/5 and I take that 3/5 and I multiply it by 2, top and bottom, do I change the value of the fraction? No. So we all are in agreement that if I have a fraction, I can multiply it as long as I'm multiplying the denominator by the same number I'm multiplying the numerator by, that it's creating an equivalent fraction. So I'm not really changing its quantity, I'm just changing its appearance, right? Okay, so when I give you the problem, even though it looks a little bit more intimidating, it's the same idea here. When I give you that same original problem where it was, oops, let's write this out, 3/4 plus 1/2 all over 5/6 minus 7/12. Right, so this is my original problem. That's a fraction, right? This is a fraction. There's that really long fraction bar. This is a fraction. Can I multiply the denominator and numerator by the same thing and I'm not changing the value because I'm multiplying both the numerator and denominator by the same thing? So now the strategy here is going to be like, okay, well, what am I going to multiply it by to actually help me out? So you're going to look at all the possible denominators. We have a 4, we have a 2, we have a 6, we have a 12. What would be a common denominator for all 4 of these? 12. You're going to multiply the bottom by 12 and the top by 12. So then we multiply the whole bottom by 12 and the whole numerator by 12. Now I'm not changing the value because I'm multiplying by 12/12, which is 1, right? I'm not changing the value. But because the numerator is a binomial, wouldn't that 12 have to get distributed in? And because the denominator is a binomial, wouldn't that 12 have to get distributed in? So what is really happening here? This is going to be 12 times 3/4 plus 12 times 1/2 all over 12 times 5/6 minus 12 times 7/12. And when you're multiplying fractions, what are we allowed to do? When you're multiplying fractions, what are we allowed to do? Cross simplify, exactly. 4 goes into 12 3 times, 2 goes into 12 6 times, 6 goes into 12 twice, and 12 goes into 12 one time. David gave me bathroom? Yeah. All right, now let's keep going. In the numerator, what am I left with? I'm left with 3 times 3, which is 9, plus 6 times 1, which is 6. And in the denominator, I'm left with 2 times 5, which is 10, minus 1 times 7, which is 7. Let's keep going. 9 plus 6 is 15. 10 minus 7 is 3. 15 divided by 3 is 5. Did we get the same answer both ways? Yeah. All right, are we ready to step this up to Algebra 2 now? All right, so from here on out, I'm only going to use the second method. From here on out, I'm only going to use the second method. So let's look at this next problem. So we have 2 over x plus 3 over xy all over 3 over x squared plus 1 over 5. Don't write this down. I just want to have a little bit of a chat. In this problem, the first one I wrote down, can I multiply everything by the common denominator and essentially eliminate the denominators in this first one? Yeah, I can multiply everything by the common denominator and eliminate the denominators. Would I be able to do that here? Can I multiply by xy and eliminate the denominators? Why? How come I'm allowed to do it here, but I'm not allowed to do it here? Matthew.
Because if you were to like multiply by the LCM on the right equation, there's no really way to like counter, like, for example, in an equation you can multiply by the other side, but in this case there is no other side, so you can't just...
Exactly. This wouldn't be legal, right? Because this isn't an equation. You wouldn't be keeping it balanced. You're essentially just canceling things out that aren't allowed to be. But here, when I multiply by the top and bottom by the same thing, I'm really multiplying by one whole, right? And does anything change when you multiply by one whole? No. Does everybody see the big difference of why I'm allowed to cancel out here, but I'm not allowed to cancel out here? Because that's a major concept right now. Okay, so I'm going to go and I'm going to look at all the denominators. We have an x, we have an xy, we have an x squared, and we have a 5. Would the common denominator be, wouldn't it be 5x squared y? So that's what we're going to multiply by. I'm going to multiply by 5x squared y on top, and I'm going to multiply by 5x squared y on the bottom. Vanya, you okay?
Yeah.
I just wrote it to the right because I had no room. All right, but because the numerator is a binomial, don't I have to distribute that 5x squared y in? So this is going to be 5x squared y times 2 over x plus 5x squared y times 3 over xy over, distribute that 5x squared y in. So we're 5x squared y times 3 over x squared plus 5x squared y times 1 over 5. This x and one of these x's go away, right? An x squared divided by x is just an x. Here, x, y completely cancel, so I'm just left with a 5x. In this one, the x squared completely cancels, and this one, the 5 completely cancels. So that brings us to, let's see, 5xy times 2 is a 10xy. 5x times 3 is a 15x. In the denominator, I have a 5y times 3 is a 15y. And then x squared y times 1 is just an x squared y. So, remember what I've been saying the whole time. Is there more I can do here? I can pull out GCF on top and bottom. If I pull out GCF on top and bottom, will it help me by canceling anything else out? No, I hope you have the foresight to see that it won't. But if you don't, what should you do to be safe? Just pull it out just to be safe. Right. We know it won't, right? Are you guys taking my word on that? We can leave it like this, right? All right. Next one. How about you all try this next one on your own before I step it up? It's number 2. So you're going to do this next one on your own before I step it up and make it harder. So starting point was a little bit different here. Before you, well, you didn't have to do too much, but before you chose the GCF, the LCD, shouldn't you factor these first before choosing what the LCD would be and multiplying by it?
For the last question, if you factored it, would the factor form still be correct?
Of course. I'll come to you.
So it's the whole x plus 5x minus 1, so you can multiply everything by x. You multiply the numerator by x plus 5x minus 5, you multiply the denominator by x plus 5x minus 5. You're getting
I got it right.
It's okay. Keep
That's good.
This, the whole denominator cancels, right? And for this one, just the x minus 5 cancels, so. That one, yeah, but then we still have the 2x up here too, so, right? So it's x plus. Yeah, there you go, that one's the numerator. And then the denominator, yeah. So then you're gonna go for 20, but then for the next one, they both get canceled, so it's just plus 3. Better? All right.
Tell me, first let's get an answer, then we can go through it. Someone tell me, what did you get? What did you get? Rach.
7x plus 25 over 4x minus 17.
4x minus 17. Anybody get anything different? Good job. All right, who needs to see me do this? We're good? Okay, let's keep going. All right, we're going to step it up now. Did you say, can we not? Oh, okay. Without stepping up? I wish I didn't have to. It's not bad. No, that's what you can't do. So that's where I was. Sorry, I'm sorry I said it like that. But I was actually so happy that you said that, because that's everybody's instinctive thing, is to flip the whole thing. So why can't we just flip the whole thing? Chris? Because there's an addition sign, exactly. This addition sign is not raised to a negative. All right, the x is raised to the negative, the y is raised to the negative, but this addition sign, linking them together, connecting them as a family, is not raised to a negative. It would be very different if the whole quantity of x plus y was like raised to a negative exponent. If the whole numerator was raised to the negative, then we could put the whole numerator in the denominator. But this is saying just this x is negative, just this y is negative, but the plus sign linking them together and making them stay attached to each other is not raised to a negative. So we cannot just move it to the denominator. That's not an option here. You can actually recognize this as what? A difference of cubes, right? I mean, a sum of cubes. You can recognize it as a sum of cubes. I wouldn't do it that way, but some people do see it that way and are able to do it. What I would do here is I would still rectify the negative, and I would say, okay, well, I know this has to stay up top above this fraction bar, right? But x to the negative third power, that's the same as saying 1 over x to the third. Yes? Plus y to the negative third power, isn't that the same as saying 1 over y to the third? Same thing with the denominator. X to the negative first power is the same as saying 1 over x to the first plus 1 over y to the first. So now, haven't we just been dealing with problems that look very similar to this right now? Moral of the story is, can I just switch them? Can I just flip them? No, the whole numerator is not raised to the negative to just flip it. We cannot do that. So now we're going to go ahead, and what are we going to choose? X cubed, y cubed. Who said it? Chris? Good. So we're going to multiply x cubed, y cubed on the bottom, and x cubed, y cubed on the top. This is allowed because it's multiplying a fraction numerator and denominator by the same thing. It's like multiplying by 1. We're not changing its value. So now this is the same as saying x cubed, y cubed times 1 over x cubed plus x cubed, y cubed times 1 over y cubed all over x cubed, y cubed times 1 over x plus x cubed, y cubed times 1 over y. We can cross simplify, so the x cubes cancel here, the y cubes cancel here. One x cancels with one of these x's, and one of these y's cancel with one of those y's. So what are we left with here? Y to the third plus x to the third over, what is this here? X squared y cubed plus x cubed y squared. How many people think we're done here? How many people say nope? How many people say, I know we're not done, but I don't know what to do? Okay, so no, we're not done. You don't know what to do. Y cubed plus x cubed, what is that? Cubes, sum of cubes. Can't we factor that? In the denominator, can I pull out a GCF? Maybe you don't know if anything will cancel, but if you don't know if anything will cancel, should you factor to make sure? Yes. So let's go ahead and factor. So we're going to have y plus x. Guys, you're distracting me. We're going to have y plus x, and then we're going to have y squared minus xy plus x squared. And in my denominator, can I pull out an x squared y squared? And when I pull out an x squared y squared, I'm left with y plus x. Does something cancel? Yeah, the y plus x's cancel. So now I'm left with y squared minus xy plus x squared all over x squared y squared. You want to try one of these? You want to... Okay, try this. Ready? 5. So I know you've all started. I'm assuming most people made similar to what we did before, made fractions. When you're making your fraction, is the 6 going to the denominator or just the x? Just the x. The 6 does not move down. Why doesn't the 6 move down? Why doesn't the 6 move down? Good, because only the x has the negative. It's not the quantity of 6x raised to the negative first power. Just the x is raised to the negative first power. So the 6 stays in the numerator. The x goes to that denominator. So your numerator would look like this. 1 minus 6 over x plus 5 over x squared. And then your big fraction bar. How many people did I get? Okay, don't let me get you again. Don't let me get you on the test. I could get you in class, but not on the test. All right, are we ready or you need more time? More time? Okay. So just so you know, at this point, your denominator should have looked like this. Yes? Good. All right. Who has an answer for me? Who has an answer? David.
X minus 1 over x plus 2.
Did anybody get anything different? Okay.
I didn't get anything.
You didn't get anything? So you didn't get anything different. You just didn't get anything? All right. Well, then you all win if you got this answer because that was the correct answer. Do you want me to do it?
Yeah.
Let's go through it. Did you get to this part?
Yeah.
Okay. So now what are we multiplying everything by? What would be that common denominator if we were to choose one?
X squared.
X squared. So I'm going to multiply x squared on the bottom, x squared on top. So then we're going to get x squared. Oops, sorry, I'll write it out. So we're going to have x squared times 1 minus x squared times 6 over x plus x squared times 5 over x squared all over x squared times 1 minus x squared times 3 over x minus x squared times 10 over x squared. All right, this x and one of these x's cancel. This cancels out completely. This x and one of these x's cancels, and this cancels out completely, right? So in the numerator, I'm left with x squared minus 6x plus 5. And in the denominator, I'm left with x squared minus 3x minus 10. But now I'm left with a trinomial in the numerator and trinomial in the denominator. Can we factor those? Yeah, so then we are x minus 5, x minus 1. And in the denominator, it is x minus 5, x plus 2. So the x minus 5's cancel. So that leaves us with an x minus 1, x plus 2. All right, are we ready for the doozy? Yes.
What is that wrong? Just like coming back from the very beginning.
Nope, you wouldn't be wrong. You'd be good.
Oh, but I still got the wrong answer.
You shouldn't have been. You should have been able to get the right answer.
I probably did something.
Okay. All right. So here, are we ready for the doozy? Are you ready for it? You have to be neat here. And David, you need a new sheet of paper. Claire. Yep, if you started and just factored, you're good. You're going to get the right answer. All right, so what number am I up to? 6. Start a new sheet. Start a new sheet. Yeah.
What is it? This is oh, why? Oh, it's so good. Where do you start? Wait.
I'm going to tell you, just follow along. It's going to be tedious. What do I always tell you? Thank you, Aaron. Thank you for listening to me. I appreciate it. And Tasia says, but wait, is it going to be on the test? All right, have we written it down correctly? Yes. Okay. So I'm seeing stacked fractions. Are you seeing stacked fractions? So what I'm going to do is I'm going to take a group of stacked fraction. I'm going to like split it into sections. So I'm going to start here with my first stacked fraction. Okay. And then I'm going to go over to the side of my paper and I'm going to work with that first stacked fraction. 1 over 2 minus 1 over 2 minus x. Well, that 1 over, you might be used to seeing it like this. But can't we write 1 as 1 over 1? So it's like fraction on top, big fraction bar, fraction on the bottom. This is what we've been doing this whole class. So what do I tell you to do? Look at all the denominators and choose a LCD. What would be the LCD here? 2 minus x. But now I'm going to multiply everything by that 2 minus x. So the 2 minus x gets multiplied on top. The 2 minus x gets multiplied on the bottom. So in the numerator, it's going to be 2 minus x times 1. And in the denominator, it's going to be a 2 minus x times 2 minus a 2 minus x times 1 over 2 minus x. Is it okay that this time I'm multiplying by a binomial? Is that okay? Yeah, it's fine. No, don't say that. Okay, so in the numerator, it's just a 2 minus x. In the denominator, don't I have to distribute in that too? So this is going to be 4 minus 2x. Don't these 2 minus x's cancel? So then it's just minus 1. There's still that minus 1 there. So what does this become? 2 minus x over 3 minus 2x. I'll give you a second to catch up. So now, it's a process. It takes forever. So now this whole thing gets substituted in to that box. So stay with me. All right, so I'm going to rewrite the whole problem over again. So this was 2 minus 1 over 2 minus 1 over 2 minus, now we substitute in 2 minus x over 3 minus 2x. So now we're working our way up. Now we take our next stacked problem. What is our next stacked portion? No. Don't know where that even came from. Okay. Isn't this it? Right here, 1 over 2 minus x over 3 minus 2x. All right, so now what am I going to do? This blue box, everybody needs to be able to hear me. So now I'm going to take this blue box, I'm going to go over to the side and I'm going to simplify it. So we are 1, if you like writing it the 1 over 1 to make it look like what we've been doing, that's fine. Over 2 minus x over 3 minus 2x. Do you agree we're going to multiply numerator and denominator by 3 minus 2x? All right, so our new numerator is going to be 3 minus 2x. And then on the denominator, I'm going to get 6 minus 4x. Do you guys see what I'm doing without actually writing it out? So I'm getting 6 minus 4x. Then the 3 minus 2x's cancel, so I just need to distribute in that negative. So it's going to be minus 2 plus x. Did I lose anybody? Because I didn't show you my every step.
Can you put the first one back into the fraction? You have to distribute that negative. Should the 2 minus x be in parentheses, or is it just
I don't know where you're at right now.
like when you put when the yellow arrow is pointing?
Yeah.
You put that back in, so in that blue box.
Yes, that whole thing, that,
So
look.
it should be 2 minus 2 plus x. Or
No, it's 2 minus now this whole box, right? So this minus will get distributed. Look how I wrote it. 2 minus, and now it's not just minus the bottom. It's 2 minus this whole
no,
complex.
The 2 in the bottom. Like with the 2 minus x.
Yeah, so this should be in parentheses. Okay, let's keep going. So now what am I going to be left with? 3 minus 2x over 4 minus 3x. Now what are we going to do? We're going to take this and substitute it into that box we had boxed off. So what is it now left down to? We're now left to 1 over 2 minus 3 minus 2x over 4 minus 3x. Did I lose something? Was there another? Oh, this was a 2. No, we're good, right? Is this? No, I have it. Okay. So now what are we going to do? We are going to simplify this. So this is the same as saying 1 over 1 over 2. I can't have all the side talk. 2 minus 3 minus 2x over 4 minus 3x. Do you agree we're multiplying everything now by 4 minus 3x? Okay, so we're going to multiply the numerator by 4 minus 3x, and we're going to multiply the denominator by 4 minus 3x. So our new numerator is 4 minus 3x. our denominator is going to be, I'm distributing in that too, so it's 8 minus 6x, and then minus 3 plus 2x. Let's keep going. We now have 4 minus 3x all over 5 minus 4x. Yes? Yes, 5 minus 4x. We're going to take that and we're going to substitute it in. Because remember, it was 2 minus that whole thing, right? So now it's going to be 2 minus 4 minus 3x over 5 minus 4x. Can I cancel out the denominator now? Can I multiply everything by 5 minus 4x? No, this isn't a stacked fraction. Stay. This is not a stacked fraction. What do we have to do? Create a common denominator. So my common denominator is going to be a 5 minus 4x. So we're going to have 2 times 5 minus 4x minus 4 minus 3x over 5 minus 4x. Distribute that in. It's 10 minus 8x over 5 minus 4x. And now distribute in that negative. So it's minus 4 plus 3x. We end up with 6 minus 5x over 5 minus 4x is your final answer. All right, now you can go. Homework will be posted. Homework will be posted. Claudia, can you stay? Could you stay during lunch and I can help you?
Sure.
It's funny, I like did it right, and I just got this.